All right, like I said, this will be a quick one. We're talking transformations, and basically these are things that we kind of know already, so I won't go into too much depth here, but like when you're talking about like the max or the min value, just so you can see what the heck this is talking about, C is, when you're talking about the equation here, right, like if we're thinking about a sine function, like you have the A in front, remember A, K, D, C, K, X minus D, plus C, right? So this A, and Grady kind of mentioned that as well, A is the amplitude, but you never have a negative value for amplitude, so that's why they write, remember the absolute value function, that kind of thing, it means it's always a positive number. So if it says like -2, your amplitude is 2, like you take the positive amount of that. So that is what your amplitude is. You also can get it by taking the max minus min divided by 2, but that's only useful if you have a graph, right? Like I see the graph and I want to know what the amplitude is. That's not really like helpful if you already know it from the equation there. So this is the same, if you just replace cos, it's the same kind of equation there. I'll zoom in on that for you so you can see that a little bit. When we're talking about the max or min value though, just so you understand what the heck these things are saying, C kind of is the like center line, right? It's kind of like ocean level, and so if you have a function like this, like a sine function, I can figure out the maximum, and you can look over here, right, to see what the maximum equation is. It's your amplitude plus C. And so if your C is like at 2, right, and your amplitude is, for instance, if it's 3, 2 plus 3 gives you a maximum of 5, right? And this over here, this says, hey, if you could also wrote this like C minus A. I feel like that's easier to understand. But if you started at 2 and went down 3, right, your minimum would be at -1. It's basically just saying, hey, take your center line and add the amplitude or subtract the amplitude to get the max or min. That kind of makes sense? Yeah? All right, good. Amplitude, obviously, if you didn't know it already, you'd go 5 minus -1, that'd be 6, divided by 2 gives you 3, right? So that kind of makes sense in that example there as well. And then the axis of the curve, it says y equals, axis of the curve is again, that's kind of like the center line, C. So amplitude is basically, right, that's your absolute value of A. C is kind of like your max plus your min divided by 2, that's finding the average, and so on and so on. So let's go ahead and kind of look at maybe just the graphs of these. We'll do a little sketch, but basically these are not set up right now in the form that we need, right? The form that we need is y equals cos, and then we would need some sort of like k, right? So you have to factor out that 2, and when you do that, you have to do pi over 2 divided by 2, right? And so when you do that, that's actually just going to be well, pi over 2 divided by 2, that's pi over 2 times 1 over 2, right? Yeah, pi over 4. So x minus pi over 4. All right, so a couple things about this, right? When we're looking at this equation here, the A is equal to 1, so I know that my amplitude is 1. I know that my period, right? Period is a big capital P. Do you remember the formula for period before, like in grade 11? You probably don't, eh? No. Yeah, divided by K, exactly. So it was 360 divided by K. So our grade 12 version, instead of 360 divided by K, it's, yeah, exactly, 2 pi divided by K. So we'll write that in here. And we actually should probably write that at the top somewhere because it's not on here. If you want to write that, period equals 2 pi divided by K up top, that'd be awesome. So in this case, the period is 2 pi divided by K is 2, right? So the period is pi. So instead of its regular 2 pi long, it is pi long here. C being the center line or the axis of the curve. I call it center line because C for center line makes so much more sense. Sorry, I'll zoom in on that for everybody there. Is basically 0 here, right? Because there's no plus anything, so C is 0. And basically, it's been shifted right pi pi over 4.
At this point, we're asking you to start taking attendance to submit your attendance. We know all the
All right, wait, let's stop talking about, I'm now recording. We can't have that as a legal recording. We're not gonna do this example because we need the room. But basically now, right, you could do the mapping thing. And so there's two ways of doing this. Hey, Marlon? Yeah, we marked you late. You're the only kid in the building going to be marked late today, but that's all right. We didn't want to mark you absent because we didn't want them going to look for you. So, just so we're clear, right, like for cosec, like the regular function, I'll just show you the regular points for cosec, right? If we were to do transformations, you'd have 0, pi over 2, pi, let me zoom in, 3 pi over 2, and 2 pi. And we know cos starts at a maximum, so it's 1, 0, negative 1, 0, 1. If you did grade 11 math, you would have kind of remembered those points, right? But basically, we know all you do to get our new function, right, is x divided by k plus d and ay plus c. And so in this case here, right, our x is 2, so you'd have x divided by 2, and it's, remember, it's plus d, so plus pi over 4. And in terms of these here, right, a is 1, so 1y plus 0. So the y's literally don't change at all. So your new function of x, and I'm going to forget the equation here, y equals cos 2x minus pi over 4. Basically, right, your y's are going to stay the same. So you're going to get 1, 0, negative 1, 0, 1, because you're timesing them by 1 and adding 0. But your x's, you need to divide them by 2 and then add pi over 4. So kind of annoying, but 0 divided by 2 is 0 plus pi over 4. You get pi over 4, right? Pi over 2 divided by 2, that's pi over 4 plus pi over 4. A quarter plus a quarter is a half. Pi over 2 plus pi over 4, that's 3 pi over 4. You'll notice now that these are basically just going up by a quarter. So if you did the fourth one here, right, 3 pi over 2 divided by 2, that'd be 3 pi over 4 plus pi over 4, you're going to get a full pi. And then I know that they're just going up by, like, this is 1 pi over 4, 2 pi over 4, 3 pi over 5, 4 pi over 4. This one would be 5 pi over 4. So that would be your new function, and you could go ahead and graph that. We're not going to do that because I didn't give you guys an axes, because I'm a jerk, and we'll just leave it like that. But you guys could all graph that now. That's kind of how you do it. If you're good with transformations, right, you could just go ahead, like we're going to show you from looking at a graph, because I find that's harder. You don't have to do the mapping diagram. You could just have taken a cosine function, shifted it to the right pi over 4, you know, and then done the period of pi and figured it out from there. But I feel like this is the foolproof way, right? Should be pretty good. Number 2, there's an infinite number of answers for these, which is why I hate marking tests like this, right? Because technically, like, we all should have the same amplitude, the same axis of the curve or center line, the same period, right, so the same k value, but literally there's an infinite amount of d's, shifts, that you could choose because it's been, like, shifted, you could say it's shifted here or here, like there's an infinite amount of them, right? So my hope is to show you a quick trick, and then hopefully if everyone follows the trick, we got the same answer. But yeah, what's that with it?
So for cosine, we would just do a d value that's half a pi more than the sine value.
Unfortunately, that will totally depend on the period. You would need it to do a quarter of the period, right? Because you're totally right. Like if it was half a pi more than the sine values shift, then yeah, I mean it would be, that would make sense if the period was 2 pi, right? Because then it's exactly right there. But if it's been extended or shrunk down, it's not half a pi shifted to the right anymore. It would be like a quarter of the period, which your pi over 2, that's a quarter of 2 pi, right? So you can think about it that way, absolutely. Here's another way to think about it, because you are right, William, if it's 2 pi, right? So one thing that I like to think about is, let's first of all, let's get A, C, and K, because those are quite easy, right? So what is our A value here? And our A value, we're just going to take as your amplitude. We're always going to do a positive A. I'm going to show you how to make that true. So our maximum looks like it's at 5, and the minimum is at negative 11, by the looks of it, right? The scale's 1, yeah, so maximum is at 5, minimum is at negative 11. So remember, if you look at your formula for your amplitude, right, it's max minus min divided by 2. So max minus negative 11 divided by 2, that's 16 divided by 2, so our amplitude is 8. C would be the center here. Remember, this one actually is labeled, which is nice for us. You can see it's at negative 3 here, which is really handy. But if we didn't know that, right, all you would need to do is add them together. So 5 plus negative 11 divided by 2. And if you do that, my brain hurts. That is 5 minus 11. Let's just do 11. Yeah, thank you. Could I not do that? Negative 6 over 2, which is negative 3. They obviously show us that here, but sometimes it's hard to see that. Then what we need to do is to get the K, right? And so Corey helped us remember, he said that the period is 2 pi divided by K, which means that if you switch K and pi, K is 2 pi divided by the period, right? So I think it's easiest to look for a period from maximum to maximum here. For me, that is the most simple because I can see those exactly. So I see from negative 2 pi over 3 all the way to pi over 3. Like if you subtracted those, right? Like pi over 3, that's a 2, minus negative 2 pi over 3, that'd be pi plus 2 pi, that's 3 pi over 3. Our period is pi, right? From here to here, that distance is pi. So our period is pi, which means our K is 2 pi divided by pi. You're going to get 2, right? Any questions on those so far? Getting your A, your amplitude, your center line, or your period? You feel good about that? Yeah. The 2 pi over 3 thing?
Yeah.
So I'm just finding the distance. You don't need to, but this was me saying I want to find the distance between pi over 3 and negative 2 pi over 3. So I'm just subtracting those two values to find the distance there. So pi over 3, that's this value. Subtract negative 2 pi over 3. So tell me the distance between the two, which is pi there. Cool. All right. And here's the last one is D. D is the most difficult, and your A, C, and K, these are always the same for sine and cosine. And I don't know if you need to make a little note about that, but let's say same for sine / cosine. The only thing that's different is the D value, and so we're going to write a little thing here for D, and basically when you're thinking about the D value, the shift, you want to think about a regular pattern of sine and cos. And so just so we're clear, for sine typically, right, starts at the center line, goes up, and ends like that, right? That's one cycle of sine. And so all you have to do is just find one spot where this begins, where this center line happens, and you're going to name that D. And for cosine, we know cosine, right, if we're talking about the center line here, cosine always starts at a maximum. That was ugly. But basically that value right there, wherever it starts, I don't need to put that one in red, but that would be the D value, is wherever the maximum starts. So sine, you're just going to find a pattern that starts for sine, and cosine, you're looking for a pattern where it starts for cosine. So it is really as simple as that. I can see right here, notice how they give us this point? This point right here is pi over 12, right? And so if I was to almost take a highlighter here, this section is a sine function, right? That looks like a sine function. I'm going to erase that because that is hideous. But what we would say then, the d value for a sine function, you just do pi over 12. So our equation is y equals, remember our amplitude was, I have a terrible memory, I actually don't know. Thank you, 8. So 8 sine, our k is 2. And then you're going to go x minus, and you just choose the d value that we picked right there, right? The one where it started, which is pi over 12. And then add c, which is, I guess in this case, it's minus 3. And for cosine, you're going to have the same a, 8 cos, same k, same c. The only thing that's different is going to be the d value here. And again, all you have to do is pick one spot where there is a maximum. Any of them will be true. Pi over 3 can work, negative 2 pi over 3 can work. Any of those will work because really, right, your original function starts at a max, and you're basically just saying, I'm shifting it to the right pi over 3, or to the left negative 2 pi over 3. So I'm going to pick the first positive one I see, and I'm going to write minus pi over 3. Yeah, William, what's up, buddy? You had a question there?
No, I was just going to say that.
Oh, shoot, sorry, I was spoiling your thunder there, my bad. Yeah, absolutely. So those work. Again, if you can find a spot where that pattern begins, you can choose any single one of those. And to go off of what William was saying earlier, if we took pi over 12 and we added a quarter of the period, right, adding a quarter of pi, so pi over 12 plus pi over 4, you would get pi over 3. So that would all work in William's favor as well there. I just find when you think about this right here, that makes things pretty simple for you. All right, I promised that we'd keep it short, so we'll just do those two today. I'm going to hit the stop.